Here's a little help with a couple problems that came up actually let's pass this, I think it was 26 that was the big one, so I'm going to fast forward a little bit. If you needed help with 15, I've got that as well. But let's go to 26. That was a doozy, and I think I've got a couple of you hung up, and rightfully so. It's kind of content we were going to get to in the next couple of days, but the help videos on this were really helpful, and I noticed some of you were able to manage just dealing with that and using the online text and things like that. So way to go for those that you got it, and if you didn't, that's all right too. Check this out. Here's what's happening is you're given some information about, for a particular price, this is how many tickets were sold, and remember that's a demand thing. So we've done the equation of a demand curve before, where you're given for a certain price, this is how much was sold, $4 for 48,000, $5 for 42,000. What you do is you create a line, you connect those two dots with a line, and we need the equation of that. It's called the demand curve, and it's not curved at all. It happens to be linear, but we still call it the demand curve. Often it can be curved. So that place where this fits in is demand is actually like the price people are willing to pay for something. So I just highlighted that P in that equation for what's called revenue. Revenue, R of X, equals X times P. What that means is demand really is what people are willing to pay at a particular, if you want to sell so many units, we want to know what they're willing to pay. And then of course the money we take in, the revenue we get, is the price people are paying, that P, times the number of units X that they sell. So X times P gives you your revenue, and P stands for the price people are paying, and it comes from our demand information. So I'm going to scoot to the next page and kind of plot those 2 points. So let's get our demand curve. So for 48,000 people if I get that many customers, I have to have $4 as my price. And then if $5 is my price, I lose 6,000. I'm only selling 42,000. Classic demand issue. So you increase the price, fewer people want it. And so there's the demand curve. It's actually a line. You'd connect it and make it linear. I'm going to get the slope of that because if I'm going to get the equation of that line, slope is the first stop. So you do the y's, subtract them, and then subtract the x's in the same order in the denominator. That simplifies to negative 4,000. If I made an error, just let me know. And then we'll put that negative 4,000 in for slope because that's our demand slope. And so let me put a couple things in there. So there's negative 4,000 goes in for M. And the 48,000 that I just plugged in there is just a point that I chose. Remember, you can choose any point that you want to plug in here. So if I choose to put 48,000 in here, then I need to put 4 over here in for X. Or if I choose 42,000 for that Y1, then I need to choose 5 for the X that goes over there. So just the normal stuff. So I put in 4 to go with that 48,000, negative 4,000 for the slope. There's my equation of my demand curve. We will solve for Y. And we want to make sure that once you solve for Y, you simplify just to save yourself some trouble. So I added 48,000 over to the right-hand side. I distributed the negative 4,000 to each of these. Remember, that makes this positive 16,000 inside. Just little details, and then we want to add the 16 and the 48,000. There you are, 64,000. This right here, that's our demand curve. Anyway, what it does is, you notice, it gives me the P price, and I'll put P back in there. Price per, and then given a number of units that you plug in there. So actually this one's actually turned around. So what we'll do is, this one's okay. We just call this our demand curve, and I think I actually have the variables kind of turned around the way I have number of units and price flipped around. In the end, what's going to happen is it's not going to affect the way this is calculated. It still works. What happens is you often can invert these and write them sideways one way or the other, the x or the y-axis in any order. But that'll work. That little curve there, if you plug it back in here, this will be all that we need to finish out this problem. If I go back a page, you can use that equation P to plug in for revenue, and then you get a nice revenue function, X times this price thing that I just came up with. And then cost, I think most of you are able to come up with cost. Cost was the 0.1 cents per unit plus 85,000 of fixed expenses. And then ultimately revenue, if you want to look past that, whoops, you're going to go back a little bit. Revenue is when you take, profit is when you take revenue minus cost. And so the big P of X would be whatever your revenue function is minus your cost function. And all this you wouldn't have to simplify very much as far as putting it into that part A up there. There's a lot of forgiveness that goes with good old my WebAssign when it deals with this type of thing. So you can plug in your revenue minus cost functions, no need to simplify. This is going to look like x times your demand function minus this cost function that you already have. And you just plug them in as is. You can find a curve that kind of matches with that. But this is one of those where you can, I'm going to go ahead and back to WebAssign and lower the amount of points that this is worth. Again, you can watch the videos that go with it. It won't hurt you. And then leave that for something to ask when I see you guys next in class. Thanks.